Hello everyone, welcome to Guidance Education channel. We are continuing class 12 physics chapter 2 electrostatic potential and capacitance. Subtopic is combination of capacitors. We have already discussed combination of capacitors in series. Now we will see combination of capacitors in parallel. If you have not watched series combination of capacitors, please click the I button in order to watch that. Under that video, we have seen that the effective capacitance Cs, that is reciprocal of effective capacitance Cs, is equal to 1 by C1 plus 1 by C2 plus 1 by C3, etc. The effective capacitance is much less than the least capacitance of the capacitor connected in series. Okay. Now let us see what happens in the case of parallel connection. But before we start the class, please watch the video completely without skipping. And if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks, valuable feedbacks as comments in the comment box below. If you have not subscribed my channel, do subscribe it now. Subscriptions are totally free as usual. Press the bell button and all button for notification of more videos like this. Thank you very much for your support. Come, let us start. Now let us see how the capacitors are connected in parallel. This is capacitor 1, 2 and 3. The first plate of the capacitors is connected together and the second plate is connected together. The connected ends A and B are connected to the positive and negative of a battery in external circuit. Let the voltage of the battery, that is the potential difference, be equal to V. Let the capacitance of the three capacitors be equal to C1, C2 and C3. Now the capacitors get charged and let us suppose a charge equal to Q is drawn from the battery and supplied to the capacitors. This charge Q gets distributed among the three capacitors C1, C2 and C3. The capacitance of the three capacitors are different. So the charge stored also will be different. We have the formula Q is equal to C multiplied by V. The potential difference of these three capacitors will be the same because the second plate is connected to the negative terminal of the battery and the first plate is connected to the positive terminal of the battery, and it is equal to the potential difference of the battery V. Though all the capacitors have the same potential difference, the capacitance is different, C1, C2 and C3. So the charge stored will be Q1, Q2 and Q3. Q1 is equal to C1V, Q2 is equal to C2V and Q3 is equal to C3V. We have seen that Q is distributed among the three capacitors. So Q is equal to Q1 plus Q2 plus Q3. Now let us see the effective capacitance. The individual capacitance of the capacitors is C1, C2 and C3. We will use the symbol Cp for effective capacitance in parallel combinations. So Cp is equal to effective capacitance. P for parallel. Substituting for Q, Q is equal to Cpv. So Q is equal to Q1 plus Q2 plus Q3 becomes Cpv is equal to C1v plus C2v plus C3v. V on the left hand side and right hand side get cancelled. So what remains is Cp is equal to C1 plus C2 plus C3. So when the capacitors are connected in parallel, the effective capacitance is very much increased. It will be greater than the maximum capacitance in the circuit. There is no need to take an example in order to understand this fact. Yet, let us consider one. Let the first capacitance be 1 microfarad, second one 2 microfarad, and third one 3 microfarad. Then the effective capacitance Cp will be the total of this 3 plus 2 plus 1, that is 6 microfarad. The greatest capacitance is 3 microfarad in the circuit. The effective capacitance is much greater than 3. In this case, it is double that of the greatest capacitance in the circuit. You will recall that when resistors are connected in parallel, their effective resistance will be the sum of the reciprocals of the individual resistance in the circuit. If the video was useful, don't hesitate to subscribe my channel. As you know, educational videos have limited audience. Thank you very much. We will meet in the next video with the next important topic. Till then, bye. Take care.